Greetings everyone. Welcome to Kite lecture series. My name is Aman Jolly and today we would be discussing about cloud usage scenarios. So in previous videos the basics of cloud computing were discussed, so you must be aware of the buzzword cloud computing. Today we would be discussing about the different usage scenarios based on different models on which the present, or maybe I would say some kind of cloud computing scenarios were based, or some kind of cloud computing scenario is still going on. Okay, so these are the contents that we would be going to discuss in this video. So starting with the history of cloud computing, evolution of cloud computing, then major players in cloud computing, then we would discuss about business models around clouds, then the underlying principles of parallel and distributed computing. So let's start with the history. Okay, so when we talk about history of cloud computing or evolution of cloud computing, these two words in the context of cloud can be used interchangeably, right? But in this specific video I have segregated these two terms. In the history of cloud computing, we would be studying about the forefathers of cloud. Cloud computing is itself an evolved product and it has gone through many stages, right? So we'll start with the basic overall timeline of the computation in the history of cloud computing, and then in the evolution we will discuss all the key phases that made cloud computing what it is today. So basically we would be discussing about the more I would say the important milestones that formulated the cloud computing. So let's start with the history first. So in cloud computing, networking is one of the key element. So before moving on to the computation part, we just look at the networking part, right? Earlier, before I would say before the emerging of the cloud computing, before the emergence of the cloud computing, there was a client server computing architecture, which is basically a centralized architecture, or I would say there was a centralized node, right? We can also call this as a server that contains all the data, right? And if someone wants to have access to that data, he or she needs to log into their device, which is a client, and then he has to connect to the server. Then he or she has to gain the appropriate access, and then he or she can do her business. Well, if he wants to gain an access to a file, once the access is being granted by the server, you can access the file. So in this approach, there is one centralized server, there is one centralized node, and which is having all the data, which is having all the storage files, and different clients are requesting for those files, and based on their request, server is granting the access to those files, right? This was the basic concept of client server model. Then after that, distributed computing came into picture, where all computers were networked together and they all share their resources when needed. In distributed computing, one of the key advantages was not a single computer was having all the data. Every computer, in distributed computing, not a single computer was having all the data. All the nodes were having some sort of data and they shared their resources. Later on, distributed computing became a big picture, and that cloud computing, this client server architecture became the part of distributed computing. So later it became a broader term. Client server computing became a part of distributed computing. Now we have discussed all the network part.
Okay, so on the basis of above computing, there was emerged of cloud computing concept that later implemented. So in 1960s, Professor J.C.R. Licklider introduced a term, intergalactic computer network. The intergalactic computer network was, you can say, the very first step towards cloud computing. This word. So basically, Professor J.C.R. Licklider was responsible for enabling the development of Advanced Research Project Agency Network ARPANET in 1969. Now, you might have heard about ARPANET. It was the very first networking system that was made. I won't say it internet, but you can say it is a father of internet, because the very first networking was made with this ARPANET. Right? Now, in 1961, John McCarthy suggested in a speech at MIT that computing can be sold like a utility, just like water or electricity. So this might be a familiar term in cloud computing, and actually this was a very brilliant idea at that point of time, because no one has ever thought about it. See, at that point, even at that point of time, we used to pay for water that we used to pay for electricity, but no one has ever thought about using the computation power, and based on the usage of that computation power of computing resources, you would have to pay per computation. So that was the whole concept of utility. So in 1961, John McCarthy used this term utility, which suggested that the computation can be sold just like water and electricity. It was a brilliant idea, but like all the brilliant ideas, it was ahead of its time. As for the generation, few decades, despite interest in the model, technology simply was not ready for it.
So in 1999, there was a company whose name was Force.com. He launched a venture with the name Salesforce.com and delivered its first product, its first application over to an enterprises over an internet. So it was the first time where an application was delivered to an enterprise over an internet. So 1999 is a very important milestone if we talk about using software as a service. So it was the very first example where software was delivered over a network. Right. In 2002, AWS started Amazon Web Services. See, in 2002, AWS was started, right? But in 2006, it was actually made viable for general public. So basically, they made their commercial service version open to public in 2006. Now, in AWS, they started providing services like storage, computation, and even human intelligence, right? And after 2006, right, 2009 was a very important year, because in 2009, almost every big name that you have heard in the field of cloud, every big name, started their own venture and started giving some cloud-based services. As you can see, Google came into the picture. Google came into this cloud business, and they have started start Google Apps. And in 2009, Microsoft launched Windows Azure, and companies like Oracle, HP have all joined the game. So this proves that today the cloud computing has become the mainstream. Now, let's talk about the evolution of cloud computing. So, in the evolution of cloud computing, as I have told you before, basically all the important milestone that formulated cloud computing is being discussed. So we have divided this evolution of cloud computing into 4 phases. First is grid computing, second is utility computing, third is software as a service, and fourth is the cloud computing. So as we are moving towards the higher phases, the abstraction of the computational resources is being increased. The abstraction is increasing, the simplification is increases, and the capability aggregation is also increases. Means the features, the overall features is getting increased day by day. So let's talk about the first phase, grid computing. We will discuss all these phases in detail later. Let's just have a gist what it is all about. In grid computing, basically a large problem is divided into smaller chunks, and those problems are handled by different computers. So you can say the grid computer is a process of solving large problems with the help of parallel computing. Parallel computing means there is a problem, and instead of handling that problem sequentially, we are dividing the problem into n number of chunks, and we are feeding those problems to multiple computers, and all those computers that may or may not be tightly coupled. They maybe those computers would not be sharing same LAN, or maybe the computers which are solving this problem may be very far from each other. Maybe their geographical location is too much high. So irrespective of the distance, they are solving a problem parallelly. Now in utility computing, as we have discussed before, utility, just as we use electricity, just as we use water, and we use it as a metered services, we use it as measured services, which means that the more you use water, the more you have to pay. The more you use electricity, the more electricity bill that you will receive. So in that way, we would be offering computer resources as a metered services. Now when we talk about computing resources, it includes networking capabilities, it includes storage capabilities of computers, it includes computational capabilities of the computers, right? So computing resources means we would be sharing computation, we would be sharing the storage capabilities, we would be sharing network capabilities of a computer to a user, and that user will pay as he uses. As per their usage, they will have to pay, right? So now the third phase is software as a service. Now in software as a service, we would be using applications which would be hosted on certain websites, and that would be doing certain tasks. For example, YouTube it can be regarded as software as a service because it is a streaming platform, and you don't know the background. You are just using the software. You are just using a cloud service. In fact, this PPT, I made this PPT on prezi.com, right? It itself is a software as a service, right? And after the software as a service, it emerges as cloud computing, which is the final phase that we all know. So as we are moving towards higher phases, the abstraction is getting increased, which means that in earlier phases we used to know the type of hardware that we are using for computation, but as far as we are moving towards as we are moving towards higher phases, the type of hardware, the type of operating system that we are using for computation, it hardly matters. The abstraction is getting increased. In grid say for example, in grid computing, I would be using many computers to solve a large problem. This was the fact, right? And if you are using large computers, you must be knowing about their hardware architecture, you must be knowing about the operating system. But if you talk about cloud computing, if you talk about software as a service, you really don't know. You don't know what type of operating system your service is being your application is being hosted. For example, I really don't know Prezi is the Prezi.com on which I am presenting this presentation is being hosted on Linux server, or it is being hosted on on Windows operating system. So as we are moving towards the higher level, the abstraction is getting increased. Simplification is things are becoming much simpler because abstraction leads to simplification, and obviously the capabilities, the functionalities are getting increased. So this was the evolution of cloud computing. Let's talk about some basic terminologies. Okay, so first terminology is cluster computing. Okay, if we talk about cluster computing, it is the group of computers connected to each other and work together as a single computer. These computers are often linked through a LAN. Okay, so basically there is a group of computers and they are connected with each other via LAN. If we are talking about LAN, it means local area network. So from this statement, this thing is clear that all those computers that are connected with each other are in a very close proximity. They are not very much far from each other, right? Now the second point is the cluster is tightly coupled system, and from its characteristic, it is a centralized job management and scheduling system. So yes, if I said about LAN, they just work through LAN, it means they are highly coupled system, they are tightly coupled systems, and they work together closely as if a single computer is working. So in order to implement this, the first thing that you need is to have a centralized job management and scheduling system. It means that there must be a master system, right, who must be controlling all those systems, right? So this is the key difference between that you will observe in cluster computing and grid computing. In grid computing, you will get confused in grid computing and cluster computing because both of them are systems, and both of them are group of systems that are working together to solve a particular problem. But here you can see that these systems are having centralized job management and scheduling system. They are having decentralized job management scheduling system, right? Okay, we'll talk about that in later slides. Let's see the third point. All the computers in the cluster use the same hardware operating system. Okay, so they are saying that all computers are at the same physical location and connected with a very high speed connection to perform as a single computer. So one important point of cluster computing is that all the computers are the replicas of each other. When I say replicas of each other, it means that the operating system of all the computers and the hardware configuration of all the computers are same. They are the images of each other, right? So this is one of the important point that you have to note, because this point is a key point of cluster computing, right? And let's see the last point. The resources of the clusters are managed by centralized resource manager. Yes, they are managed by centralized resource manager, and this thing has been discussed. Now, as far as the architecture is concerned, it contains some of the main components, which are multiple standalone computers. Obviously, if you are planning to have a cluster computer, you must be having standalone computers, operating system, and not only operating system, same operating system, because every computer is identical and they work together as a single computer, so they must be identical. Now third one is high performance interconnect. When you are having all those computers, you need a connection setup, so, and that would be having a very high performance. So high performance connects all those computers. Fourth is communication software. You need a communication software to establish an interface between all those computers, so that you can communicate with each other, with each computer, each and every computing unit. Fourth is different application. Obviously you need different applications to work on it. Now let's talk about grid computing. Grid computing is a combination of resources from multiple administrative domains to reach a common target. and this group of computers can be distributed on several locations, and each a group of grids can be connected to each other. So here also we are having multiple computers, set of computers which are connected with each other, but here they have used the word multiple administrative domains. This means that there is no concept of having a centralized scheduling system. When they are saying multiple administrative domains, then there are more than one administrator, and every node is an administrator itself. So here there is you can say a decentralized approach. In cluster computing there was having a centralized approach, but in grid computing it is a decentralized approach, right? So the computers in the grid are not required to be in the same physical location. They don't need to have, yes, that's what I wanted to say, that in cluster computing it was required that all computers must be in a very close proximity. They must be in a LAN. But in grid computer they need not to be in the close proximity. They can be operated from a remote location. So the computers in grid are not required to be in the same physical location, and they can be operated independently. Yes, they can be independent operatively. So each computer on this grid is connected to a distinct computer. Yes. So when we talk about distinct computer, there in cluster computing we talked about single image. We talk about replica, means every computer must be having, in cluster computing every computer must be having same software, same operating system, same hardware. But in grid computing they don't need to have same operating system. This is what the third point is saying. The third point is saying is that the computers in the grid are not tied only on operating system and run different. Okay, the computers in the grid are not tied to only one operating system and can run on different OS and different hardwares. When it comes to large product, grid divides it to multiple computers and they can easily use the resource. Yes. Now, as far as utility computers are concerned, I have already talked about this. There's nothing much I have to say. Basically, the whole idea was using computation resource as a service. Let's read this point and let's see if we can find something new. Utility computing refers to a type of computing technology and business model which provides services and computing resources to customers such as storage, application, and computation power. This packaging of computing service is the foundation of the shift to a on-demand computing, software as a service, and cloud computing model, which later developed as the idea of computing, application, and network as a service. All these things we would be discussing this later on. So there's nothing much to concern if you are not understanding anything. So utility computing is a kind of virtualization, which means that whole web storage and computation power which is available to user is much larger than the single term sharing system. Obviously it is a kind of virtualization where we don't know what is going behind. So and at the back end there are multiple servers, so the space that would be provided is far much better than single I would say on-premises system, or I would say the single time sharing system. Multiple backend web servers used to make this kind of web services possible. Yes, there at backend there are multiple web servers which is used to make these services possible. Utility computing is similar to cloud computing, and it is often requires a cloud-led infrastructure. Obviously it would be similar because it is the preliminary stage of cloud computing. So all the features, all the characters that cloud computing is having, they must be all those features are inherited from utility computing. You provide computation, you provide computing resources, and then you have to pay for it, and you have to pay for what you use. So this is the comparison chart of cluster computing, grid computing, utility computing, and cloud computing. So you see, you don't need to cram all these things. We just need to focus on some key features, because if there is a comparison, if the comparison comes in the exam, you just have to write only those features which are different, and which you can pause this video and you can read all about this. But the thing which is beneficial for you is just to focus on all those points which makes a difference, because many points, if you can see, are same, because the disadvantages of grid computing, utility computing, cloud computing are almost same, advantages are almost same. So just focus on the point where the actual difference is. So as far as cluster computer is concerned, all the computers in cluster computing are tightly coupled systems. It means they are in a close proximity, they are in a LAN. Second is single system image. Single system image means they all are replicas of each other, all are having the same softwares, all are having same operating system, all are having same hardware configuration. And third is centralized job management and scheduling. Centralized job management scheduling, that there is a central server, there is a master server who is controlling all the images, right? In grid computing, they all are loosely coupled. They don't need to be on same geographical location. They can occur on all those computers can be on different geographical locations. Diversity and dynamism. Obviously, all those computers must be having different hardwares, different operating system. They can have different hardwares, they can have different operating system. So there is no need to there is no problem of maintaining the same computer image. There is no problem of maintaining same hardware, same operating system version, same hardware configuration, right? And the third important point is distributed job management and scheduling. Distributed job management and scheduling is that the work is being distributed among different computers and no one is the master. Everyone has some task to do, right? In utility computing, scalability, demand, pricing, all these features are similar to cloud computing. So you don't need to cram all these things. Just remember that in utility computing, you would be working on services which are metered, which are measured services, pay per computation services. The more you compute, the more you use computing resources, the more you pay. The less you use, the less you pay. In cloud computing, there are 5 features: on-demand self-servicing, broad network access, resource pooling, rapid elasticity, widget services. All these features you have studied in the previous videos. So there is nothing much new that I have to discuss. There is a very interesting example that I can relate to if you are still confused with cluster computing and grid computing. If you have seen the movie Matrix 3, the last one, where there was a final face off between Neo, our hero Neo, with hundreds and thousands of that agent virus, Agent Smith, right? So all of them, so that can be the example of cluster computing. I mean, all those Agent Smith were having a task to kill Neo, right? And they were working as a single computer. You can say they were having a similar single task, and all of them were controlled by one that the main agent. And this is the example of, you can say, cluster computing. And as far as grid computing is concerned, you can take the example of Avengers. Why I said Avengers? Because every Avenger is unique in their own way. Every Avenger, they don't need to be in close proximity. Every Avenger is having their own background story, and every Avenger is having their own ending story, but they all come together to fight to a common enemy, which is known as Thanos. And to be very frank, I don't think they were controlled by a single man. I mean, you can talk about Nick Fury, but they were actually, it is an excellent example of distributed system, because Nick Fury actually divide, or we would say Captain America would divide the task, that you have to do that one, you have to do that task, right? So everyone is having some unique features, and but they all came together to defeat Thanos. So this would be an example. It's not a perfect one, but I think you can consider this example. Okay, so that's all for today, guys. We'll cover the remaining topics in the next video. Thank you so much. Don't forget to like and subscribe, and to all of us I say, greatness is coming. Thank you so much. Jai Hind.